Hello everyone, welcome to this presentation. Today's topic is mass, volume and density. The question we are tackling today reads, the diagram below shows a child's toy consisting of 3 solid plastic bricks fitting together to form a cone whose base radius AB is 10.5 and then its height is 24 centimeters. So the height is AR. So we have the diagram here. A up to R is 24 centimeters and then AB is 10.5. And then if AM is equal to MN, which is equal to NR, and the density of the plastic used is 0.3 grams per cubic centimeters, find the mass of the shaded brick. So we are told that AM, MN, and RN are all equal. In the question, we are asked to find the mass of the shaded brick, which is the frustum, and mass is given as density times volume. And already in the question we know what the density is, so we're only left with the volume to determine, and then we'll be good to go to get the mass. So let's determine the volume of frustum. So we are going to determine the base radius of the frustum. So let's call this R, and then the upper one R lowercase. So how do we determine this R? We are going to apply similarity here. Remember, in this diagram we have 3 cones which are similar. So we have the bigger one, and we have this other one, and finally the smaller one, the uppermost one. So using those cones, we can determine R as follows. So we are going to take the ratio of the corresponding lengths of the similar solids. So if we are to consider the bigger cone and this other one whose base radius is R, we are going to say the bigger cone has its base radius 10.5, and we'll have to divide that by the base radius of this other cone here, which is R, and this should be the same as the ratio of the heights. So we're told that these lengths AM, MN, and NR are all equal. So they are in equal parts. So we can just label them 1, 1, 1. So they are in the ratio 1 to 1 to 1. So we will have the whole of this length RA represented by 3 parts, so that we have 3 over the height of this other cone. It is in 2 parts, so we'll have to divide by 2. So from this, we are able to get the radius of that cone, which will be the base radius of our frustum. So cross multiplying, we are going to have 2 by 10.5, that is 21, which is equal to R times 3, that is 3R. That means R is 7. Continuing the same way, we will have to determine the radius R, that is for the top of the frustum. So following the same procedure, we are going to compare the bigger cone and the smaller cone whose base radius is R. So the bigger cone has base radius 10.5 over the base radius of the smaller cone R, which should be equal to the height of the bigger cone. Now we'll look at it in the parts as I mentioned earlier on. So we have 3 parts all over. Now for this cone, it's only 1 part, so all over 1. So from here, when you cross multiply, we'll say 3R is equal to 10.5, and therefore R is, when you divide both sides by 3, we are going to get 3.5. Now these are in centimeters. Now with this ready, we can therefore proceed on to determine the volume of the frustum that is required. So we'll have the volume of the frustum calculated as 1/3 times pi times the height of the frustum into the base radius of the frustum, that is r squared, plus the top radius, that is r squared, and then we will have to add these to the product of the two ready. Now this will give us the volume of the frustum. Now let us note that the height of the frustum is just 1/3 of the total height. Remember the total height, the total height here, AR, you are given as 24, and we are only interested in MN. MN is just 1/3 of 24. So we are going to say the height of the frustum is 1/3 times 24, which is 8. So we can now proceed on to do our substitutions in this formula. We have 1/3 times pi is 22/7 times the height, which is 8, and then we'll have to multiply this by r squared. R is 7, so that is 49, plus this r lowercase squared, that is 3.5 squared. 3.5 squared is 12.25, plus 7 times, that is r times r, 7 times 3.5. So we are going to have 22 times 8, that is 176. On the denominator, 3 times 7 is 21. And then this multiplies by, now when we add all this inside the bracket worked out, we should get 85.75. So this worked out is 718 2/3 cubic centimeters. So with the volume of the frustum, we can therefore continue to get the mass. Now mass becomes density times volume, and the density is 0.3. Then this is multiplied by the volume, which is 718 2/3. Now this is 215.6 grams. And with this, we mark the end of the solution to this problem. I want to thank you for watching. Hope to see you in the next video. Bye.